Okay, here are the 5.2 notes, power functions. This is page 5, so let's do a couple of examples. So we're going to graph this polynomial function just as a reminder. If p of x is a polynomial function of degree n, the graph has at most n real zeros. A little different than what I set up here was that the function has n zeros. We may have some complex zeros. They may not be all real. But if we're graphing, we're not really worried about the complex ones. Again, I have 4 terms. So I am going to factor by grouping. I can take an x squared out of these first 2 terms. I get 2x plus 1. I can take a negative 4 out of these last 2 terms. I get 2x plus 1. 2x plus 1 times x squared minus 4. Looks like everything is going to have multiplicity 1. And my zeros are, by setting my factors equal to 0, x is negative 1/2, x is 2, and x is negative 2. I'm going to start by graphing those. There's my negative 2, my negative 1/2, and my positive 2. I can find my y-intercept by looking at the constant term. So I'm going to use that information as well. If I plug in 0, I get negative 4. If I want to be precise, I could plug in negative 1. Just kind of get an idea of what it looks like between negative 2 and negative 1. Don't really have to. I've got key points here. I am, though, going to look at my leading coefficient. It's a positive 2, so I know my graph goes up to the right, which matches what I have here. So I am just going to kind of sketch in. Again, I could plug in negative 1 and 1 to figure out how low it goes. We want to sketch, so we're looking for general information here. General shape. Up to the right, because of that positive leading coefficient, I have hit all the points I found there on the left. My x-intercepts, my y-intercept, and I've used my leading coefficient to inform me on what the end behavior is. Okay. I now have a function that I am not sure of how to start. It's not as easy as my cubic or my quadratic. So we're going to go back to what we know about rational root theorem. And we are going to take a minute to think about what our possible roots are. Okay. I know all of my p's are factors of this constant term. So plus or minus 1, 2, 4, 8, and 16. And my leading coefficient is 1. So I don't have to worry about that. Everything is over q, over 1. So nothing super surprising or sketchy there. Okay. I really don't want to start by trying 16. I'm going to avoid that. I'm going to avoid the 8 if I can. But I'm going to go ahead and set up my synthetic division here. My coefficients are 1, negative 7, 12, 4, and negative 16. I am not missing any terms, so I am not plugging a 0 in anywhere. I'm going to start with a little bit of a trick. I'm going to add all my coefficients together. If I can add them together and I get a 0, then I know that 1 should work. So I've got 1x to the 4th minus 7x to the 3rd. My 1 minus 7 is negative 6. There's my 1, there's my minus 7. I'm at negative 6. Plus 12 is positive 6. Plus 4 is 16. Minus 16 is 0. Sorry, I was having a mental break there as I was trying to add. So I'm going to go ahead and use 1. So we add straight down. 1 plus nothing is 1. As I move across the line, I multiply by my special number in the box there. So 1 times 1 is 1. Negative 7 plus 1 is negative 6. Times 1 is negative 6. 12 minus 6 is 6. Times 1 is 6. How did I screw that up? 10 minus 16 gives me a negative 6. So positive 1 does not work. I lied. Jeez. See what being sick does for you? Anyway, since that does not work, I'm going to go ahead and cross that out. I'm going to try something else. And those of you watching saying that does not add to 0, should have said something. So let's try 2. I'm going to bring 1 down, multiply by 2 going across. I got negative 7 plus 2. I'm going all the way back up to the top. I get a negative 5. 2 times negative 5 is negative 10. Plus 12 is positive 2. 2 times 2 is 4. 4 plus 4 is 8. 2 times 8 is 16. Negative 16 plus 16 is 0. Cool. That one worked. One thing I do want to point out is there is no reason to not try 2 again. Notice my constant term now is an 8. So I know that these 16s are no longer going to work. Just for fun, I'm going to try 2 again. 1, 2 times 1 is 2. Negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. 2 plus negative 6 is negative 4. Times 2 is negative 8. Again, we get a 0. So if I factor this at this point, I got x minus 2 times x minus 2, and my depressed equation right here is now a quadratic. I can factor that. So x minus 2, x minus 2. I got x and x. 4 times 1. So we got what? Negative 4 plus 1. My zeros are x equal 2. That's got multiplicity 2. I got x equal 4 and x equal negative 1. Those both have multiplicity 1. So I got negative 1, I got 2, I got 4. 2 is multiplicity 2, so I know that's going to hit and bounce off. I could also plug in 0 to find my y-intercept, which is going to be negative 16. Again, I did not give enough room for that. Whatever. So I have an even degree. I got a power of 4. My leading coefficient is positive 1, so I know that both of my ends are going up here. At negative 1, it's multiplicity 1. This is going way far down. Use your imagination. It's coming back up, and I've got a multiplicity 2 at 2, so it's going to touch and bounce off. It's so not pretty there. Let me come back. And then up to where it crosses at 4. And again, the recording is done. You are more than welcome to log out or shut this down.